Having added the stationary tube sheet, our next step is to put in the rest of the components of the heat exchanger. This includes components like the tube bundle, floating tube sheet, floating head, etc. We insert a simple name and description for the tube bundle. We have two location options for attaching the tube bundle on the stationary tube sheet. We move on to the Design Data chapter. We notice that in the Process Cards Input chapter, the tube bundle has the combination of shell and tube side process card. We move on to the Tube Bundle Design Data Input chapter. We choose the Seamless Pipe option. External pressure test factor is usually equal to 1.3 for ASME code. For more information, you can contact our support team. Now we move on to the tube bundle geometry data. We enter the geometry data for the tube bundle. Tube corrosion allowance is unique and independent from process cards. It's usually equal to 0 for tube bundles. We input the modulus of elasticity. We select the TM3 copper alloys table. And we choose C44300. We move on to the Data for Baffle Plates input chapter. We select the Include option for baffle plates and start filling in their dimensions. Usually, baffle plates aren't important in tube bundle consideration. However, in order to have a better calculation of the tube bundle's weight, we choose to include baffle plates in this example. We don't input baffle corrosion allowance since the baffle plates are made of copper alloy. We choose SB111 for the tube bundle material. We choose SB171 for the baffle plate material. We don't add any component liquid and click on Calculation Details to save the tube bundle. We exit back to the vessel view. Let's check the 3D view of the vessel. Here we see that the tube bundle has been placed in the correct position inside the main shell. Here is where we are going to place the floating tube sheet. Now we are going to make the floating tube sheet. We enter a simple name and description and use component dimensions just like to copy the floating tube sheet. We attach the floating tube sheet to the end of the tube bundle and move on to the Design Data Input chapter. Despite having copied all of the data from the stationary tube sheet, we will need to make some changes. We select Floating Tube Sheet from Type of Tube Sheet. We choose Configuration Type C. We move on to the Load Cases Input chapter. Here we see that the override for corrosion allowance has been copied over from the stationary tube sheet. We move on to the Data for Tube Sheet Input chapter. We set the outside diameter of tube sheet to 432 mm. We move on to the Data for Tubes and Tubes Layout Input chapter. No changes are needed in this chapter, so we move on. We open the Flange Data Input chapter. The floating tube sheet has not been connected to a flange yet, so we will have to specify some inputs manually. We choose the Dimensions Provided by User option in Compatible Components. We enter some logical dimension inputs considering that the tube sheet is not connected to the bolted domed end yet. We input gasket load reaction equals 419 mm. We input 500 N for the two following inputs. We input 419 mm for the midpoint of contact. After we have considered the floating head and the backing ring, we will return here to input the correct dimensions. We save the tube sheet by clicking on Calculation Details. We exit back to the vessel view. We click on the 3D button to view the floating tube sheet. The last step remaining is to add the bolted domed end and the backing ring on the floating tube sheet.